Welcome to Configuring and Managing Storage in Kubernetes course. In a container orchestrator, such as Kubernetes, stateless services, such as microservices, lend themselves well to the underlying architecture because, well, they are stateless, and the containers can be scheduled on any node without worrying about affinity to a particular node or local storage provisioning. In non-trivial situations, however, such as performing operations such as sorting large amount of data or checkpoint markers, while certain events will need to occur, temporary local storage is required, and often data saved locally must survive container or infrastructure crashes. Furthermore, many databases are deployed as containers. They require permanent storage that must survive the infrastructure or container crashes. And finally, it is desired to abstract storage implementation details from pod definition to provide maximum portability. Next, we will examine how Kubernetes fulfills these requirements. First, let's take a look at how Kubernetes fulfills our first requirement, and that is providing temporary storage for our containers. It introduces what is known as ephemeral volumes. So ephemeral means non-permanent or temporary. And there are a number of volumes of this type that is listed here. Let's go through those and take a look at what they are. The first one, empty there, is basically the node that the pod is scheduled on. It allocates some disk space and then exposes that as mount point inside the container. And the container can use that for temporary operations such as sorting or other operation as it needs to. The next type is called generic ephemeral volume. So on those require actually special drivers. They're very similar to empty there. They provide some other features such as they can be network attached. So empty there, they're local to that node, but generic ephemeral could be network attached. And also they could contain initial data. Empty there does not allow that. So you can create data later on, but it does not allow you to load initial data. Next one is similar to the other two, and which is CSI, ephemeral volumes. So CSI stands for Container Storage Interface. This is an interface introduced to enable storage vendors to create custom storage plugins without actually changing any of the Kubernetes source code. So you can think of it like CNI or Container Network Interface, where third parties such as Calico, they can provide pod networking without making any changes to the Kubernetes source code. So, or CRI, which is Container Runtime Interface, which you could plug in various types of container management without actually recompiling Kubernetes, the same idea. And the last three types, that is config map, downward API, and secret, they are special types of ephemeral storage, and they are primarily used to inject Kubernetes configuration as mount point inside the containers. I will cover those topics in a future presentation, but just suffice it to say those are very specific types of ephemeral storage. As for our second requirement, that is providing permanent storage for our pods, Kubernetes provides what's known as persistent volumes. And as you can see, there are quite a few of type of volumes that can be used from various vendors, can be used within Kubernetes. Broadly speaking, however, they fall under three categories: network, such as NFS or Azure File, or block, such as Fiber Channel or iSCSI, or cloud-based, such as AWS, GC, or Azure. In any case, an administrator can expose these volumes to the client so a client can use them in their pod. And they can do that through two different ways. One is more of a manual provisioning by creating persistent volume. So for each client needs, we specify a persistent volume, and that basically is an abstraction over the type of volume that is being used and the amount of space. And I'll show you how to create that during our demo. They can also do it more proactively or automatically through automatic provisioning through storage classes. So in a storage class again is an abstraction over the type of volume that's being used. However, the advantage is an administrator can assign a block of storage, depending on which one type is being used, and that is being exposed, and then the client can claim that, and those are automatically provisioned, so there is no human interaction. The other advantage of using storage classes is, depending on need, for instance, for mission critical applications, an administrator can specify SSD for that storage class type, but for everything else, maybe use NFS. The other feature of this is an administrator can define a default storage class. So if you don't specify that, for instance, say NFS is our default storage class. So if we don't specify that, it always uses NFS. In either case, either automatic or manual, a client will need to create an object called PersistentClaim in order to actually claim the storage that has been created by the administrator. And like everything else in Kubernetes, it's got a version, and API version and so on. I'll go through that in more detail during the demo. One thing that I just want to show you here is you have to specify under the spec storage class, under spec, either if you use storage class, we specify the class name that is going to be used, or if it's persistent volume, then we need to specify the persistent. So the syntax between these two, changes slightly depending on which type is being used. Again, I'll be showing you during the demo. The other thing then, we have to specify how much of this space are we going to need that. And then the last thing that we need to do is create or actually request our pod. In this case, we create a deployment object. I'm not showing the whole deployment object. I'm just going to show the part that is relevant to our discussion, and that is the section that we specify the container, and which is under the spec. We have to specify the volumes and the keyword volumes, and we specify a name for it. And then we have to say what claim. So we need to specify the claim name that we created here. And as you can see, this now fulfills our third requirement, and that is abstracting the details of the storage and volumes from our pod. And the only thing it really nodes is, we have to specify here is just the claim name. The other thing that we have to specify is where do you want this allocated space storage to be mounted inside the container, and that is the path to it. When we execute this deployment YAML, the command line is command is kubectl apply -f and the name of the YAML file. Then the request goes through the control plane, which calls into kubectl, and kubectl mounts that volume locally onto that node. And if there are multiple nodes and we have multiple pods on each one of those nodes, then each node will mount that volume again. And then kubectl call into CRI, which actually creates the pod, and then mounts that or exposes that amount that the volume that we mounted here inside the pod. And this name is actually corresponds, the name, the location of this mount is is where we specified it previously. So now this pod has the volume available to it for whatever operation that it needs to do. And then lastly, CRI calls into CNI and then actually creates the networking part of this pod. The rest of this video is going to be all demos. I just wanted to share with you the lab setup. Pretty simple. I have a single node Kubernetes cluster. I also have a server that acts as a storage server. For this demo, I'm going to use NFS as the permanent storage that we talked about. I will provide all the scripts required to set your environment up. I have another video that shows you how to set up your cluster, Kubernetes cluster. If you haven't set up your cluster yet, I'll provide a link up here so you can go ahead and set it up. I also provide scripts to set up your NFS on the server. And you don't actually need two servers. Maybe if you only have one server, you can actually install NFS server and client on the same machine. And I'll provide the instructions during the demos. In our first demo, we are going to see ephemeral directory or volumes in action. Let's take a look at the YAML file that is going to implement this demo. So the kind would be deployment. You can also use pod if you like, because you don't really need deployment here, but really doesn't matter, either deployment or pod. And then kind of use the rest of this is nothing really different here than what you do normally. And the only difference would be under spec, and this is where we deal with the containers. So we have the containers here, and then the image that we're going to use, and this is going to be an Nginx demo, a container, and we specify a name for it. And then this is where we kind of is related to our discussion here under volumes. The mount path, so this is where the volume will be loaded, and it will be under cache in the root. And then the name, we specify a name for this volume mount, and we call it volume, cache volume. You can call it whatever you want. And under volumes, we specify no more information, and where actually will be loaded, what volume will be loaded into that. And this is where we specify empty dir. So this is empty dir ephemeral. Volume will be loaded in this folder. Okay, let's go ahead and run that on line 3. kubectl apply -f, and that is the name of our YAML. So let's go ahead and run that. And we'll see that that's created. So let's go ahead and verify to see you can see the pod. Yeah, the pod is already up and running. It's ready. Now we're going to, for convenient purposes, I'm going to capture the name of this pod, which is right here. I'm going to get that and put it into a variable. So let's go ahead and get that. Now we have the name of the pod in that pod variable. Now let's go ahead and sh into that pod. So we are now inside the pod. I'm going to change folder to cache. So this is where the volume is loaded. Let's go ahead and do that. And now we're going to create a new file, text file. Very simple. We put hello world, hello from empty dir storage into that. So let's go ahead and that's created. On line 11, let's verify that the file exists. So cat test.text. So we're going to see the content of the file we just created. So let's go ahead and exit that. Now I'm going to simulate a crash. So recall that for ephemeral volumes, when you delete a pod, it also deletes that volume. However, if it crashes for any reason, either by server or the pod or the container itself, then we should see that after it's rebooted or after it has been created, recreated, we should still have the information that we created here, which is this text file here. It should actually survive the crash. So obviously you don't want to reboot your production server, but here for testing purposes and demo purposes, I'm going to reboot this machine. And it will take a few minutes in order to for it to come back. And then once it come back, I will continue. Okay, the server was rebooted. Now let's go ahead and verify on line 18, kubectl get pods minus OY. So let's go ahead and see, make sure that a new pod was created. And as you can see, yeah, this is a new pod. Now let's go ahead and SH into that, or get the name again. So we capture the name on line 22. We're going to SH into that pod again. So kubectl exec minus IT and the name of the pod. So let's go ahead and do that. And then we change directory to cache. And let's see if that file that we created still exists. And as you can see, it still exists. So it survived the crash of our server. Okay, so once we delete the pod, then that will also go, will be deleted. Oops, I need to exit this first. Okay, so that concludes our first demo. In this demo, we are going to look at static persistent volume, specifically NFS volumes. We're going to set up NFS server and client installation process. And we will take a look at persistent volume and persistent volume claim creation. And finally, look at storage lifecycle and reclaim policies. We are back in Visual Studio Code. And the first thing that we need to do is SSH into our storage server and install the NFS server. On line 6, SSH, I'm going to SSH into my storage server. And then on line 10, and this is how we install the NFS kernel server. And so this is the, I'm using APT because I'm using Ubuntu. You're using a different version flavor of Linux. Use the appropriate package management, but the package is the same. This is the package name. So line 12, we are going to create a directory which we will be exporting or sharing out, where Kubernetes will be able to create volumes on. So go ahead on line 12. I need to put in my password again. And then we'll create a subfolder called static. That is for this demo, or for all our volume, static volume will be on this. So let's go ahead and do that. And I'm going to create another folder called dynamic. So that is for the next demo, set of demos. We'll be using dynamic provisioning. And then on line 8, we need to tell the operating system, the kernel, that we are exporting this directory here. And this is the command. We need to create a file called exports under etc subfolder. And then this is the command that we're going to use. So this is the, again, name of the directory that we are going to export. And then star means no restriction, any IP address we're able to connect to this share. RW means read, write, and no root underscore squash, and no sub tree underscore check. Basically, both of these will allow applications to mount a subdirectory of the export directory. So they will be able, Kubernetes will be able to access these two subdirectories. So let's go ahead and run that, and we can verify that on line 19, and everything looks good. So, and then on line 20, we're going to restart the NFS service. That's done, and then we exit on line 21. Next, we need to install the NFS client on all the nodes, on all the Kubernetes nodes. So in this case, I only have one node. I've already installed this, so I'm not going to reinstall that. But anyway, keep in mind, if you have multiple nodes, then you need to install the NFS client on all of them. And then before creating any persistent volume or claims, I just want to make sure that you're able to access the shard we just created, and on line 28, sudo mount -t nfs4 ubuntu VM. So this is the name of the storage server, and this is the directory that we shared, and then we're going to mount it on this /mnt. So let's go ahead and do that. I need to put my password again. And then we do a test on line 29, make sure that we see that mount. So mount, and then we pipe the result and do a grep on NFS. Let's go ahead and do that. And we indeed see that this is the storage server, and this is the directory that was shared, is mounted on /mount. So that's I want to make sure that it works. So it does. So we are good to go. So I'm going to unmount that. We don't need that for anything else. That was just for testing. Okay, now we are going to set up and create our persistent volume on line 35. Let's take a look at the YAML file that implements that. So the kind will be persistent volume. And then we select the name for it. There's the name of it. And then the namespace that this will be residing on, and default. Make sure that if you're using a different namespace, make sure you specify that namespace there. And then under access mode, we basically tell Kubernetes how the nodes will be, what kind of rights they have to this new volume. Read, write, many means all the nodes in the Kubernetes cluster will have read and write access to it. Capacity, we need to specify how much disk space we are assigning. And in this case, let's say I give it 5 gigs. And then persistent volume reclaim policy. Basically what happens is if you delete the persistent volume claim that is associated with this claim, what happens? Retain means that do not get rid of the disk space that was claimed, so, and do not share it with anybody else. So basically we need to manually delete both the persistent volume and persistent volume claim in order to reclaim that space. So we're going to do that in the demo. So there is also a setting delete for the volume types that support that. And basically when we say delete, it will release the disk that it has claimed. And it's really usually used mostly by dynamic provisioning that we're going to talk about next. For our purpose, we set it to retain. And then we have to specify the NFS information, the IP address of the server, and also the name of the folder or the directory that has been shared. So this is the share that we just created earlier. So let's go ahead and run this. We'll see that it was created. Now we can take a look at it, kubectl get persistent volume, and the name the volume that we just created. Let's go ahead and get some information. And we'll see the name and the capacity. We gave it 5 gigs. And the access mode, we specify read, write, and execute access. And then reclaim policy retain, as we mentioned earlier. The status is available because we haven't really created any claim for it. So let's go ahead now and create a persistent volume claim for this persistent volume is just created, and then this is the YAML file. The kind will be PersistentVolumeClaim, and we give it a name again, and then the namespace that it resides on. And again, we need to specify the read, the access mode. Again, we specify read, write many, so all the nodes, Kubernetes nodes will have read, write access to it. And then we need to specify resources, and under requests, we say how much of that 5 gig that was assigned to it we're going to use, and we say 1 gig of that we're going to use. So let's go ahead and run that. And that's created. Now we can take a look at, again, run kubectl get persistent volume. Let's go and run that. And we'll see that now the status is bound, right? So now this is bound to this claim. So now we have a claim that is associated with that volume. We can also look at the persistent volume claim itself on line 48. Let's go ahead and run that. And as again, we can see this is the name of the claim. It is the status is bound, and then the volume that is attached to is bound to this. So again, same information a little bit from a different perspective. And on line 50, we can also get more information through describe. So kubectl describe persistent volume and the name. So let's go ahead and run that. We get the same information that we got earlier, but the thing that we're looking for is used by. And right now, you see that is none, because we haven't loaded any, we haven't created any pod to use that volume. And then before creating the pod and actually leveraging that volume, let's go ahead and go back to our storage server. We're going to create a file here. This is kind of more of a testing to see if when the pod is loaded and we create a file here, will it be able to access this file or not? So let's go ahead and SSH back into the storage server. And then we basically create an HTML file and put it under export volume. So this is the directory that was shared. So let's go ahead and then we put a message here, hello, from our static NFS bound. So let's go ahead and run that. I need to put my password again. Okay, and then we can verify that, do a cat 955, and we see that it was successfully created. So we have that file there. Let's go ahead and exit out. Let me go ahead and get rid of this. Okay, now we are going to deploy a pod and a service. Let's go ahead and take a look at the YAML. So this time the kind will be deployment. We're doing a deployment. We set the replicas and we specify the labels. And so nothing really new here except under volumes, we specify a volume called web content. So, and then persistent claim. Here is where we specify what claim are we going to use, and this will match the name, this claim that we created here. So we specify this name over here. So basically we are saying that this pod will be using this claim in order to mount the volume. And under containers, we are going to use Nginx for this test. And it will be listening on port 80. And then we have to add this volume mount. And then the name will be web content, the one that we just specified up here. I mean, it was specify a directory for that, and that would be, we can put it anywhere we want. Put it under slash user share Nginx HTML and then a web app. So that's as far as the deployment object. Now we also deploy a service along with it in the same YAML file. So the kind will be service. This is the name of it. And again, the selector will be, the label is looking for Nginx, app Nginx. So any pod that has that, which we created up here or we defined up here, will be part of this service, and we'll be listening on port 80. So let's go ahead and run that. It successfully created. We can verify that and look at the service on line 61, kubectl get service, and the name of it. We'll see that indeed the service was created, and this is the cluster IP. Let me scroll down. And then we capture that service IP and put it in the variable for convenience sake. So let's go ahead and do that. And then on line 65, let's take a look at the pod that was created as part of the deployment. So this is the pod name, and this status is ready and running. Let's go ahead and also, again, capture the name of that pod. We put it in a variable to be used later on. And now on line 69, we're going to curl into that service, so HTTP. So this is the IP address, the cluster IP address that we captured up here. And then we're going to then call that HTML file that we created. Let's see if we can hit it and we get a response from the server. Let's go ahead and run that, and indeed we can. So this is the messages coming from that HTML file that we created earlier. So now let's go ahead and look at describing the volume, persistent volume again for that persistent volume. If we take a look at it now, we'll see that use by is populated by the name of the pod. So that pod now is using this claim, and it uses this claim to mount that volume into its directory. We can also, to further verify, we can actually SH into that pod, and that's what we do on line 77. kubectl exec -it, and this is the pod name we captured up here. And we're going to do a bash, so let's go ahead and do that. And then we do an ls under the user share Nginx HTML app. It should look familiar because this is where we specify where the volume to be mounted. So if we do an ls, we'll see that the demo.html is there, because that's what we told it to load it. And then we can do one more test, basically spit out the content of that file, and no surprise, this is again the content that we created for that HTML file. So let's exit out. Now, what node, let's see what node this pod is created on. And in this case, I only have one node, so that it's on the kube master. So now what we could do, another verification, if you recall, I mentioned during the presentation that once we have a volume created, a persistent volume created, and we have a pod that loads that volume, before doing that, actually kubectl or the kubelet will mount the volume into its folder structure, and then once we have that pod created, it makes that mount available to the pod. So we can verify that and see if we can see that mount on the server. So we do mount slash or a pipe and then pipe it into grep NFS. So we'll see that indeed, yes. So this is the IP address of the storage server, and this is the folder that is mounted, and then this is where it mounted on. So this is where actually it's mounted. So if we do an ls here now on the server itself, so sudo ls, and now lo and behold, we'll see that demo HTML. So basically we are pointing to the same thing. We created the demo.html on that folder, on that file in the on that directory on our storage server. But now all of them, both the pod and also the node itself are pointing exactly to the same location. Okay, let me go ahead and clear this. Okay, now what happens if we delete the pod on line 94? Let's go ahead and delete it. And we want to see if the data is still there. So if you know, as you know, once you delete a pod, by default, Kubernetes always create a new pod for us. So we can verify that on line 97. Let's go ahead and run that. And we'll see that indeed now we have another pod which is running. And then we can verify if the data was deleted with the pod or not. Obviously, we don't expect that to happen because this is a persistent volume, but nonetheless, let's go ahead and try that. So on line 100, we're going to call the service again. So now, remember now we have a brand new pod, and let's go ahead and call that. And again, we'll see that it exists because again, this is a persistent volume. If you delete the pod, it's not going to be deleted. It's not like ephemeral type volume that will go away. Okay, now let's do another experiment. Let's go ahead and actually increase the number of our pods to 4. And that is on line 104, kubectl scale deployment, and this is the name of our deployment, and replica is equal to 4. Let's go ahead and run that. Now let's do another describe on our persistent volume. Let's go ahead and do that. And now we'll see that it has 4 pods associated with that. So as we scale, all the new pods that are created will also have access, will be those, the volume will be mounted on each one of those. So all of them will have access to the information. So, and if we run the service that is curled into that cluster IP, if we run it multiple times, every time, as you know, Kubernetes does a lot load balancing, so all of this is coming from different pods, so which means that all the pods have access to that demo.html. Now on line 117, let's do another experiment. This time we are going to delete our deployment. So the deployment is deleted. Now let's take a look at our persistent volume and see if it's bound or not. So on line 121, let's go ahead and do that. And we'll see that this is still bound because nothing really has changed. We only delete our pod. We can also take a look at our persistent volume claim on line 125. So this means that deleting the pod has no effect on PV or PVC. So let's go ahead and recreate that pod again and deployment. And let's go ahead and do that. And then we'll take a look at the pods again on line 131. You'll see that the new pod has been created and it's running. And then, but if I delete the deployment, let's go ahead and delete the deployment. And also this time you're going to delete the persistent claim also. Let's go ahead and delete that. Now let's take a look at the persistent volume on line 141. We'll see that the status is released, but the claim is still there. So which means that nobody can actually claim this persistent volume. But if we try to recreate that PVC that we just deleted, let's go ahead on line 145, apply. Let's go ahead and do that. We'll see that it was created. Now let's deploy the application again on line 149. We see that deployment was successful. Now, if we look at the status of the pod, we'll see that is pending. Even though we recreated the PVC, the claim, but because we set the policy to retain, so that PV is not actually releasing anything. So nothing really has changed. So we are not able to create a new, so the pod is not able to actually leverage that volume. And so we see that still pending. It will never be able to successfully load that volume again because something is broken here. So if we do on line 157, PUCTL get persistent claim, let's go ahead and do that. We'll see that the status is pending. So it's not really, it cannot attach itself to the volume that was originally attached to. Even if we use the same name, the persistent volume is not releasing anything yet. So you can also look at the persistent volume itself on 158. You'll see that the status is still released. So in order to be able to actually reuse this, we need to actually delete both the PVC and PV and recreate them in order to reclaim the space. So on line 162, we are going to delete our deployment, and then we're going to delete our PVC and then our PV. And now, if we recreate again, so we're going to create our PV, and then PVC, and then if we now deploy our application, if we look at the pods, we'll see now that it's still pending. The final demo is about dynamic persistent volume provisioning. But before getting into actual code, let's review how this process works. So administrator will need to define what is known as storage classes. So storage class is really an abstraction over storage or volume type. And these storage type will provide automatic provisioners. So in other words, the administrator will not manually create this persistent volumes. Those are actually done through these automatic provisioners. So once these class or classes are defined, then the clients can request, depending on how many types of storage the administrator has defined, they can pick one, and then they create their persistent volume claim as they did before, and name it. Let's we call it PC1 in this case. And under spec, one thing they have to specify is storage class name. For instance, in this case, we are saying we want storage class 1, which is kind of provide abstraction over storage type 1. Let's say type 1 is NFS and type 2 is like Azure Disk. So this is how these are categorized by the administrator. We will also then define again the access mode as we did before, and then we specify the storage that we require. So once the user persists that request, it goes to Kubernetes, and depending on what classes we are requesting, the provisioner associated with storage class will then actually does the provisioning and create a persistent volume based on the amount of disk that we requested. And then a different user could probably request storage class 2, and the same thing. It goes to the Kubernetes, and provisioner 2 in this case now create that persistent volume. And then the user will then create their deployment as they do before, and then they specify the persistent volume claim name, in this case PC1, that is the first persistent claim that we created. And then, everything is really the same thing. And then the mount path, where do they want to this volume to be mounted on into the pod. And once that done, then Kubernetes again will provision or mount that volume, first of all, into the node, and then that becomes available to pod as a mount. So this is what we actually are going to do in this demo. We are going to install NFS automatic provisioner. Like I said, that provisioner is not built into Kubernetes, so we need to install that. We're going to use Helm. So Helm is a package manager for Kubernetes. If you haven't installed it, I'll provide instructions in the script how to set it up. Then we configure NFS to be the default storage type. So one thing an administrator can do is pick one of these storage classes that they define as the default. So when you create the persistent volume claim, then if you don't specify the type, then that type will be automatically provisioned for you. We'll also look at creating persistent volume claim and how the persistent volume is actually created. And then we'll take a look at the storage lifecycle and look at the delete policy. So in the previous demo, the policy was retain, but now for automatic provision is usually delete, and see how that differs from retain. For this demo, we're going to start fresh. So I've deleted all the persistent volumes and claims and persistent volumes. So let's go verify that we don't have anything left from the previous demo. Okay, good. Now the next thing that we need to do is we need to install the automatic provisioner for NFS. There are a couple of providers. I've selected one. We can go to I'll provide a link to the Kubernetes page. There's another one if you want to try that one as well. It's up to you. But I'm going to install it using Helm. So if you haven't installed Helm or you don't know what it is, on line 7 through 9, I have provided some links to where you can install Helm and install guide and get it started. And so basically what Helm is the package manager for Kubernetes, and it makes life a lot easier. A lot of packages are already available if you want to install stuff in Kubernetes. So Helm is really way to go. So once you install Helm, then on line 12, you need to import the repo where the provisioner is in. And this is the command that you need to run. You need to only do it once. Once you import that, then you are set. Then on line 13, this is the line we are going to actually install the provisioner. So this is the name of the package, nfs-subdir-external provisioner. And then we need to pass in a couple of important parameters here. One is NFS server. That is the IP address, or you can specify the name if you have your DNS setup. And then you also need to specify the path on that server where the provisioner will be creating the volumes. And if you recall, we created this folder in the previous demo. So let's go ahead and run that. And it's pretty quick. So we can verify the deployment. By the way, I've also provided if at some point you decide you don't want to use this provisioner anymore, this is the Helm delete, so you can delete the provisioner if you don't want, or you don't want to use it anymore. On line 18, this is how you can delete it. And then to verify the deployment on line 21, kubectl get deployment. And this is the name of the deployment that it used. So again, the same thing, nfs-subdir and the rest of it. And on line 22, take a look at the pods that is created as part of this deployment. And this is the name of the pod. So this is actually the provisioner. So the provisioner is implemented as a pod. It also installs a storage class on 25, line 25. kubectl gets storage class. If we run that, now we will see that we have, this is the name of the storage class that is generated as part of the deployment. And again, this is the name of it. So that's the name of it, and this is and the reclaim policy is delete. So we use retain in the previous example. For this, automatically it uses delete. Okay, so the next thing that we want to do is we want to set this storage class as our default provisioner. So on line 28, kubectl patch, and this is patch storage class, and NFS client. This is the storage class name that we just saw that it created for us, -p, and we need to pass this parameter or value, metadata, colon, and then annotations, colon, and then the important part is here, storage class.kubernetes.io / is default class. We set it to true. So in order to make this storage class as a default, then we need to set it to true. So let's go ahead and do that. So that's now our default storage class. Now, if you want to remove that, this is the line that you do it. If it's identical to the previous line, the only exception is you set the is default class to false, and then that will not be the default storage class anymore. Okay, let me go ahead and clear this out. And then on line 33, we are going to create a claim. So again, we need to create a persistent claim, the kind with the persistent claim. This is a name that I selected for it. And then under spec, if you don't set the storage class to NFS client, then or you don't specify any, or you don't set any default storage class, you need to specify it here. Since we already set our storage class to NFS client, I'm not going to add it here, but again, it's up to you. If you want to set your default class or not, it's really up to you. Okay, under access mode, like before, we set it to read, write, many. So all the nodes in the cluster will be able to have access to this volume when it's created. And then under request, and this is the amount of this storage that we are requesting. So let's go ahead and run that. And then let's verify on line 35, kubectl get persistent volume claim. And this is our persistent volume claim. And as you can see, they automatically created this persistent volume. And we can verify that on line 36, kubectl get persistent volume. Let's go ahead and run that. And as you can see, it's the same one that we just saw. We can also describe. So you'll see on line 37, kubectl describe persistent claim, and that's the claim name. And then what we are looking for is used by, and then right now is not being used by anyone because we haven't deployed any pod yet. So let me go ahead and clear this. And before deploying anything like before, let's go into that volume that was just created on the storage server and add a HTML file, and then we do the same test that we did for manual provision. So on line 41, I'm going to SSH to the storage server and my password. And then let's take a look at what's under export volumes dynamic. So this is the name of, this is the folder that file or the directory that it added for us once it created the volume, so this is where it actually resides. So I'm going to capture that volume name on line 43. Basically, we're just capturing this value here. And we are going to create a file, the same HTML file that we created before, basically the hello from, actually name that as dynamic. Okay, let's go ahead and run that. So I need to put in my password again. And then let's verify on line 45 cat and see if it actually created. And yes, so we have this file, HTML file now created, that demo.html. So let's exit the storage server and clear everything out. And now we are going to deploy a test pod on line 49. So let's take a look at the YAML, and it is exactly as the previous example. The only difference is now we have a different claim here, claim name. This is the one we just created. So everything is the same. And this is a mount path again, is exactly as the one that I had before. So let's go ahead and execute that. So that now is created. Now let's describe our persistent volume claim to see this volume or this pod has used it. So let's go ahead and then under used by, and now we'll see that it has a value here, and that is the name of the pod we just created. So it already has claimed it. On line 54, we are going to, again, capture the service IP for that service that we just deployed. We also are going to capture the pod name on line 55 for convenience. On line 58, let's do a describe on pod that we just created. And then we want to look under volumes and see if the has been created. So under volumes, we'll see that this is a persistent volume claim, and this is the claim name. So again, another way for us to verify that we successfully have mounted that pod, volume. We can also, let me just clear this. Another way to verify is actually search into the pod. So on line 61, kubectl exec minus IT, the pod name and bash. So let's go ahead and do that. And then we do, this is the folder we specified in our manifest. This is where the volume will be loaded, will be mounted. So let's go ahead and run that. As you can see, this is demo.html has been mounted or copied here. So, or has the pod has access to that volume. So let's exit out. And then on line 66, we are going to call the service and see that hello, that message that we created. So we have hello from our dynamic NFS mount that we just added a little bit earlier. Okay, so let's go ahead and now delete our pod. On line 69, kubectl delete -f, and this is this file here. So let's go ahead and delete the deployment. And now check to see if the persistent volume still exists. And indeed still exists, because this is persistent volume. And on volume claim, and also on line 71, kubectl get persistent volume, the volume itself. We see that that still exists, because, yeah, again, deleting the pod will not delete the volume because this is permanent. Now let's see on line 74. Let's delete the claim that we created. So we had this claim here, the persistent claim. Let's delete that and see what happens to the volume. So let's go ahead and delete that. Now on line 75, kubectl get persistent volume. And now you see that it's deleted. So And this is a difference between the retain and delete persistent volume reclaim policy. In the previous example, when we set the policy to retain, when we delete the persistent volume claim, it did not delete the persistent volume itself. But this is different. And the dynamic provisioning, almost all of them use the delete policy. But keep in mind that these are just, we are talking about the Kubernetes object, that is the persistent volume and persistent volume claim. However, on disk, it doesn't delete anything. So if you need to clean up, at least for NFS, you need to manually go into the folder that you created, the file, the directory that you set up for the volumes to reside on in the NFS server. You need to actually go in there and manually delete stuff. This concludes my course on configuring and managing storage in Kubernetes. Thanks for watching. Please check out my other videos. I have a comprehensive 6-part series on Kubernetes networking, which is probably one of the most complete series anywhere, and you can watch it here for free by clicking on this notification here. I've also recently covered Istio Service Mesh, the intro, what Service Mesh is, and also have another video on Istio security and how we can use Istio to secure your workload. You can again click up here and view it. Thank you again, and hopefully we'll see you soon.